In this second tutoring, I shall provide an outline of the three apparent proofs of the EPR argument and their main references. A knowledge of the preceding tutoring seems to be recommendable. I have also been asked to provide a quick outline of the main references underlying our three apparent proofs of the EPR argument. The first one is, of course, the historical paper 1935 by Einstein, Podolsky, and Rosen. Again, I recommend colleagues to read it because it is inspiring. The second one is the objection by Bohr that eventually continued for the rest of his life. When I first studied this paper during my PhD studies at the University of Torino, I was not impressed at all because the Bohr misses the point. Einstein does not claim quantum mechanics to be wrong. Also, it does not claim that quantum mechanics has to be changed. No, it was extremely elegant in using the word completion, namely the basis. Let's use the basis, but let's complete it when faced with the new conditions. The quantum mechanics has to be completed to represent physical reality. I like this word completed so much that I use in most of my papers, including putting it in the title of the paper. The next paper is the one by Bell, in which he introduces his celebrated disequality, which has to be assumed to be known. I cannot possibly review. Let me just recall that what essentially was proven by Bell is that a system of quantum mechanical particles with spin 1/2 does not admit a classical counterpart, period. In my studies, I have confirmed this theorem and prove it again by using even more advanced mathematics, because the statement is correct. But under basic assumptions, which have been kept silent by Bohr and all his followers, namely, the statement is correct for point-like particles in vacuum with consequential sole action at a distance interaction, since a point cannot sense any contact with any other structure. The moment those conditions are removed and Einstein conditions are considered, then Bell's inequality remains perfectly valid, but it is inapplicable. It cannot be ethically stated to be wrong. No, because it was conceived for different regions. Then the next two papers deals with the two apparent proofs of the EPR argument, which I published in the first one in 1998, dealing with the apparent recovering of a classical image for spin 1/2 particles under the condition of being extended and in deep entanglement with ensuing nonlinear, non-local, and non-potential interaction. We will review it in a second. The other papers deals with my second apparent proof, namely the apparent recovering of Einstein determinism in a progressive way depending on the density, which we will review. The other three papers in here, I prepared them for this teleconference, and they present a review as general as I possibly do in preparation for this teleconference. I would like to take the opportunity of thanking the editorial board of Ratio Mathematica that published those three papers, and I would like to thank in particular its editor-in-chief, Professor Fabrizio Maturo, for a truly incredible, comprehensive, technical, and capillary review of those papers, including not only members of the board of directors, but also a number of external technical reviewers. And therefore, I would like to state my appreciation for life to all of them. I would like to indicate that the third paper published by Ratio Mathematics this year, I present the third apparent proof of the EPR argument, that dealing most importantly with the prediction that the wave function of quantum mechanics, and I add quantum chemistry, cannot represent the entire physical and chemical reality. I would like also to indicate that in this third paper, I show that following the success of the hadronic structure model of the neutron as a bound state of a proton and electron in suitable generalized form, we have been able to show that all unstable hadron can indeed be composed by actual physical detectable particles, generally those that are produced free in the spontaneous decays with the lowest mode when the said hadrons are unstable. It is hoped that this structure model of the hadron is subjected to due scrutiny and debate because of industrial, basically novel industrial applications that we have proven with publicly traded company in the United States of America, by keeping in mind that all those industries are strictly prohibited by the conception that, of hadron as bound state of the hypothetical quarks. An important result presented in the three paper written for the teleconference is the apparent first explicit and concrete representation of strong interaction via the isotopic element of the isomathematics and isomechanics. Recall that strong interaction have not received an explicit and concrete representation by quantum mechanics since at the time of their inception in the early part of the past century. The reason is why quantum mechanics, as now has been indicated several times, can only represent interactions derivable from a potential. Now, the apparent representation of strong interaction via the isotopic element appears to confirm that strong interactions are indeed of contact and therefore of non-Hamiltonian type, as it seems to be conceptually evident if we consider the condition, the proton and neutron in a nuclear structure. They are indeed under contact interaction, and which seems to be also in agreement with the range of the strong interaction. It should be indicated that this representation of strong interaction via the isotopic element has permitted the apparently first numerically exact representation of all characteristics of the deuteron, which has been impossible via quantum mechanics for about 1 century. This result is presented in section 2.8 of the third paper here indicated. We are now sufficiently equipped for a review of my first apparent proof of the EPR argument, namely the recovering of a classical image. I wrote this paper when I was at the Joint Institute for Nuclear Research in Dublin, Russia, with an hospitality that I keep acknowledging with appreciation. This was 1994. The paper was eventually published in 1998 by Acta Applicanda Mathematica. Here is the proof. It is presented in one single page, but after the knowledge of thousands of preparatory methods. First of all, we are dealing with spin 1/2, so therefore we have to assume a two-dimensional theory. For this purpose, I assume the lifting of the associative product we studied in high school and used it throughout the 20th century into this simple form, inserting the isotopic element in between the two elements. And then I realized this isotopic element via non-unitary transform. Careful, this is non-unitary when formulated on a Hilbert space, but it can identically and uniquely represented in an iso-Hilbert space over isofield, in which case verifies, recovers the axiom of unitarity. So then I introduced this realization in honor of David Bohm and his conception of hidden variable. And in addition to that, I imposed the non-necessary condition that the determinant is 1. Even to not necessarily, I did this in purpose to show that even when the determinant of this matrix, including one single hidden variable, still then there is a classical image indeed for interior dynamical system. After this line, everything is in this line, everything else is elementary. You subject Pauli matrices, so this non-unitary transform, and you get these new matrices that do have indeed their single hidden variable in their structure. They're called now Pauli Santilli iso matrices. And then from there on, there are two lines that are redundant. Since this is an iso-unitary transform, you can be sure that the structure constant are preserved. So therefore, what we are talking about? We are talking about particles having a spin 1/2. Only they are extended. But besides being extended, they do have a spin 1/2. First of all, the new SU2 isosymmetry is necessarily isomorphic to the conventional SU2 symmetry because the structure constant have remained those of the conventional SU2. But then this is another line which is redundant, namely the iso eigenvalue of the Pauli Santilli isometric are conventional. And we are talking about indeed spin 1/2. After having done so, again the calculations are elementary. This is Bell's inequality, and but by using the isomathematics, it's easy to recompute step by step, and you end up with the corresponding quantity under isotopy is given by the Bell's quantity multiplied by this factor. It's then very easy to prove that this factor has an arbitrary value, even under the case of the terminal of the isotopic element UV21, with the consequential existence of a classical image is therefore beyond doubt. I am here to invite colleagues to express criticism, because I'm not interested in approval. I'm a scientist. I only want to be sure that indeed what we are doing is something of very serious importance for our, not only for science, but also because of the industrial implication of what we are talking that eventually we will discuss at the teleconference. However, I recommend caution before venturing criticism that they have no technical foundation. For instance, a criticism that can very easily be proffered by reading the title in the abstract only is, oh, okay, this result by Santilli, you change the coordinates and change the coordinates, it goes away. Ladies and gentlemen, this is like making the same statement. They're saying, oh, the representation of experimental data on the hydrogen atom are not valid because I changed the coordinates and the number changed. Well, let's recall that indeed this numerical representation of the spectroscopic feature of the hydrogen atom are based on the class of equivalence of quantum mechanics, which is a class of unitary transformation. If you use non-unitary transformation, then you exit physical reality, at least without the assumption of the theory. Here is exactly the same situation. The class of equivalence of isomathematical theory is given by iso-unitary transform. If you introduce strange and hyperbolic transform, you are welcome to do so, but have no apparent connection with the proof of the apparent existence of a classical image for extended particles with spin 1/2. The reason being because this result is invariant under the infinite number of iso-unitary transformation, which is the class of equivalence of the basic theory, in exactly the same way as the class of equivalence of quantum mechanics is that of unitary transformation. To review the second apparent proof of the EPR argument, we have to review the central feature of the isotopic branch of hadronic mechanics, also known as isomechanics. The theory is formulated on iso-Hilbert space over iso-field. The iso-Hilbert space is also called Hilbert-Myung-Santilli isospace in recollection of the late Professor Yeol-Chung Myung, who is one of the founders of hadronic mechanics. The main point is that all modular action have to include in a sandwich with the isotopic element. So therefore, this is the simple isotopy of the inner product. This is the simple isotopy of the normalization called isorenormalization. And this is the simple isotopy, iso-expectation value. Notice that it requires two isotopic elements because there is an action to the right and an action to the left. Next, it is essential that we review the notion of isolinear isomomentum by recalling that its realization via the conventional differential calculus dated back to Newton and Leibniz 4 centuries ago, creates unbelievable inconsistency that really have to be touched by the individual researcher to understand. It was only after decades of effort, finally we resolved those inconsistencies by formulating the iso differential calculus, which you can see here in the very definition of the isolinear momentum, which is formulated with iso partial derivative, which can be projected in the ordinary Hilbert space, in which case you see the factorization of the isotopic element, which represent the volume. The essence of the inconsistency was due to the fact that hadronic mechanics has generalized everything from point to volume, except the differential calculus, which, as conceived by Newton and Leibniz, can only be defined at a finite number of isolated points. Next, we have to recall the Schrödinger Santilli iso equations, in which, first of all, one should note that the R coordinates are iso R coordinates. Therefore, they are not points, they are volumes. We are representing particles as extended. Then you have to recall the star here, modular action between the Hamiltonian and the isostate, which is a sandwiching of the isotopic element. Then is the isopotential defined on an iso coordinates, so again acting on a volume. And finally, and most importantly, the differential part is now iso-differential, so that volumes are represented everywhere, therefore avoiding consistency. Here you should also remember that this is an iso eigenvalue, but is multiplied by the isotopic element, so by eliminating the redundant iso unit and the isotopic element, this is identically equal to a conventional eigenvalue acting on the isostate. This is very important to understand that isomathematics and isomechanics can indeed be subjected to experimental verification, because the eigenvalue is eventually a number as after eliminating redundant terms. Next, we have to remember the crucial iso commutation rules between iso coordinate and iso momentum, which are given by this expression here, again on an iso Hilbert space over iso field, and the iso commutation rule between the iso coordinate and iso momentum, which they look somewhat similar, if not identical, to the conventional one, but that is deceptive. Because you see the isocommutativity of the linear momentum ceases to exist when this expression is projected in a conventional Hilbert space. In other words, when projected in a conventional Hilbert space, isomomenta do not commute. This is a very important feature to confirm that isomechanics is a highly nonlinear theory as necessary to bypass the Bell's inequality and prove Einstein vision. Finally, we recall here the iso-Heisenberg equation, also called Heisenberg-Santilli iso equations in the infinitesimal infinite form, but I did not use them in the second proof of the EPR argument. Following the acquisitions of the indicated knowledge in isomathematics and isomechanics, the second apparent proof of the EPR argument can also be written in one single slide. I published this proof in Ratio Mathematica, and I would like to take again the opportunity of expressing my deepest appreciation to its editor-in-chief, Professor Fabrizio Maturo, as well as the very distinguished body of international pure and applied mathematicians who did a fantastic and accurate review. Well, let's begin with the recollection of the simplest possible derivation of Heisenberg uncertainty principle. More complex formulation can be easily derived thereafter. So what is the final result? The result is that the product of the standard deviation for coordinates and the standard deviation for momentum is bigger than equal to the absolute value of 1/2 the expectation value of the canonical commutation rule between coordinates and momenta, which expectation value is equal to h, and so you have the delta r, delta p is bigger or equal than half h. Well, each and every step in the derivation of the conventional Heisenberg uncertainty principle can be subjected to a unique and unambiguous, yet rather simple isotopy. By following the rules of isomathematical indicator, each and every product has to be isotopic, which means you have to sandwich the isotopic element there, but careful, because you have to reformulate the entire theory on isospaces over isofield. As a result of this process, it's rather easy to compute what we call the iso standard deviation for coordinates and iso standard deviation for momenta, which have this expression here, very similar to the conventional one, except for the presence of the isotopic element in a very strategic position. Then you redo the remaining calculation under isotopy, and you find the result that the product of the standard deviation for a coordinate and momentum is equal to the absolute value of and a half the iso expectation value of the iso commutation rule between iso coordinate and iso momentum, which is equal to t, so the isotopic element, so therefore the product of the standard deviation for coordinates and momentum is equal to ½ the value of t, but the absolute value of the isotopic element has been systematically very, very small and much smaller than the unit in all applications, including the fit of all possible experimental data. This can be found in the third volume of Elements of Hadronic Mechanics. So as a result, the product, the standard deviation for coordinates and momentum tend to zero with the isotopic element tending to zero. To make this result stronger in favor of Einstein, the presence of an isotopic element in this expression indicates that individually the standard deviation for coordinates and momentum, they tend to zero individually. So now there are a couple of comments. Technically should be iso, the standard deviation for iso coordinate and iso momentum, but I eliminated the presence of the iso unit in all members of the equations, and therefore simplify, projected in this expression. I use that projection in conventional Hilbert space. Another comment which seems to be recommendable is that in the Heisenberg uncertainty principle, there is the symbol bigger or equal, while in the iso uncertainty principle, there is the expression equal. Why so? Well, because the proton in vacuum is free to move in all possible directions. So when you do the calculation, you end up with the expression bigger or equal. Now, when instead you have a proton in the core of a star subjected to astronomical pressures, then the statistical deviations are dramatically different, if I may so. And you end up that the part that might imply bigger and equal are essentially ignorable. They are third order, so therefore should not be considered as importance in first order value. I shall also indicate that the interpretation of this result is essentially what I indicated before, namely that Einstein isodeterminism is progressively recovered in the structure of hadrons, nuclei, and stars with the increase of the density of the state considered. And that Einstein isodeterminism is identically recovered, fully recovered at the limit of gravitational collapse when the isotopic element is identical in all, as we shall see in the next slide. I would like to also indicate that I am a formula man, and therefore I'm not an expert in epistemological interpretation of these results, which of course I recommend most warmly, and I will look at them with great appreciation. An important corollary of the lemma providing an apparent proof of the Einstein isodeterminism is given by the fact that the strongly divergent quantum mechanical series are turned into strongly convergent isotopic series by therefore eliminating the divergences of quantum mechanics. This significant result is due to the fact that the Einstein determinism occurs for a very, very small absolute value of the isotopic element. But the isotopic element is sandwiched in within any product, including the product, all products occur in a perturbative series, by therefore reducing the strong convergence basically to the small value of the isotopic element. The proof of the full recovering of Einstein determinism at the limit of gravitational collapse is elementary. And it is also intriguing because it shows the close connections between our studies and historical contributions in gravitation. The proof is here in 3 lines. First, consider the historical Schwarzschild metric and decompose that metric in the product of the Minkowski metric multiplied a 4x4 matrix. Then identify the isotopic element of the preceding slide with the space part of that 4x4 matrix. Why space part? Because what we have shown, we have studied only the space aspect of the EPR argument, and we have not studied that its space-time counterpart. But this is represents precisely the Schwarzschild singularity at the limit when the coordinate reach the Schwarzschild horizon. And therefore you have as a consequence this expression that the product, the standard deviation for coordinates and momentum clearly tends to 0 when the coordinate approach the Schwarzschild horizon. The conceptual interpretation of this simple mathematical result is the following. Let us recall that the apparent second proof of the EPR argument is based on the idea that a proton in the core of a star cannot have the same uncertainty as when the same proton is free in empty space to move in all directions because of the extreme pressure that is sensed by the proton in all radial direction. Very well. But then when you pass from a position from a proton in the core of a star to the same proton inside a black hole, then the pressure becomes so divergent that the position of the coordinates and the linear momentum of that proton have to be frozen in numerical value. I would like to close this lecture with a brief review of my third apparent proof of the EPR argument, which deals with the last statement of the 1935 historical paper by Einstein, Podolsky, and Rosen, in which they state that the wave function of quantum mechanics, and I add quantum chemistry, cannot represent the entire physical reality, and I add the entire chemical reality, because this third proof has been derived in chemistry. Let us recall that quantum chemistry has made a truly historical discovery throughout the 20th century and continues to make a huge discovery almost every week or so. Nevertheless, no theory should be considered as final, no matter how beautiful and attractive may appear at a certain point in time. In my view, the most important insufficiency of quantum chemistry occurred in its fundamental notion of valence, because it misses an attractive force between the identical electron in a valence bond, with a consequential lack of a quantitative representation of molecular structures, including, incidentally, a quantitative representation of the gasoline molecule, without which I believe truly significant improvement in its combustion are rather difficult. In fact, the quantum chemistry represents valence bond essentially with nomenclature, because it misses the quantitative identification of the attractive force as established in nature by equation. In fact, for instance, the water molecule is depicted like this one with legs in between the hydrogen and oxygen molecule. By reading the most advanced treatises and papers in quantum chemistry, we do see the treatment of overlapping orbital, etc., but without a clear production of an attractive force, by therefore leaving the problem fundamentally open. On scientific grounds, the issue is, in my opinion, is incontrovertible. And I invite objection. Of course, I invite them, but under the condition that the objection are expressed with equations and not with nomenclature. Here is the fundamental equations of quantum chemistry, which is Schrödinger equation. Now, what is the most important part here? Is the Coulomb force in between the valence electron. What is sign? Plus. This means repulsion in quantum chemistry. Therefore, there is no possibility that I know to extract an attraction in quantum chemistry by using the axiom, the basic axiom of quantum mechanics for two identical electrons. If there is anybody else who can produce such an attraction, please do let me know. I recommend chemists to compute explicitly the repulsive force between the identical electron and valence bond, which is given by the Coulomb force that we learn in high school. And after substituting the constant that are very well known, it's easy to end up with a repulsive force of 230 Newton. Ladies and gentlemen, this is an astronomically large force. Newton is a macroscopic force, unit for the force. And 230 Newton is quite large, and then applied to the tiny electron, then becomes astronomically big. So, ladies and gentlemen, this is clearly one of the biggest mystery of nature that has attracted my attention, of course. Unfortunately, I have to report, by my experience, this occurrence is one of the best kept secret of the best PhD schools in chemistry, which I hope, however, will be corrected by future teachings. Also, there is a point that has to be made concerning the fact that with due exception, news media, they debate virtually everything. We are in a democratic society in America, Italy, France, Germany, England, and so therefore we are expected to debate everything, of course, in due respectful language. Now, but unfortunately, I see no scientific debates in the contemporary news media in any Western country. And I therefore allow me to recommend an editor or a journalist to fulfill their primary function, namely, please inform the people of issue of direct relevance for their own life. In this case, we are talking about a fundamental chemical notion that may eventually, in due time, improve the combustion of fossil fuel, with ensuing important implication for the entirety of mankind. My third apparent proof of the EPR argument is summarized in this slide. It essentially consists first in the adoption of the basic equation of quantum chemistry, which is the Schrödinger equation for the two electrons in a valence bond, is the Coulomb potential and the negative value indicating, in this case, repulsion. Then I subject this equation to the isotopic completion according to the rules of isomathematics, and in this case, isochemistry. Following simple calculation, this equation is reduced to the one below that shows the Halten potential, which is known to be so strong to attract the Coulomb potential at short distances, irrespective of whether positive or negative. But perhaps more importantly, this calculation shows that the Halten potential appears with the negative sign, opposite to the positive sign of the Schrödinger equation. But therefore, achieving, apparently for the first time, an attractive force between the two identical electrons of a valence pair. The proof of the APR argument, which is discussed in details in this third summary paper presented at the teleconference and recalled above, is given by the fact that the wave function of quantum chemistry cannot possibly represent the attraction among identical electrons as it occurs in nature. It's not imaginary, it is a reality. But however, by subjecting the equation to a suitable completion, then it becomes possible to achieve indeed an attraction among the identical charges. I presented this study in a comprehensive way in a monograph entitled Foundations of Hadronic Chemistry. And then with the chemist Don Shilledy of Virginia Commonwealth University, we jointly proved that this new notion of strong valence bond allows the first known, the numerically exact representation of experimental data of the hydrogen molecule in this paper and the water molecule in this second paper. I would like to close by indicating that by no means the two identical electrons in a valence bond should be considered to be the same as the beautiful, nice electron described by Feynman diagram when isolated in vacuum. Nothing could be far away from the chemical or physical reality in this case, because the two electrons are in condition of total and deep mutual entanglements of their wave packets, resulting in the activation of the Lorentz-Poincaré-Santilli isosymmetry, which implies a necessary isorenormalization of the intrinsic characteristics of the electron. In other words, the total mutual entanglement appears to have such an effect to alters the very structure of what we call an elementary charge. Therefore, it has often happened in the history of science, and of course will continue to happen. And in fact, the achievement of an attractive force between identical electrons in a valence bond, rather than ending the story, is just the beginning, because it creates a new, extremely intriguing problem, namely, what is the true structure of an so-called an elementary charge, which is such to transform an extremely strong repulsive force into an attractive force, when in the condition of total mutual penetration. I hope that this problem will attract young minds of any age. In closing, I should indicate that during the past 50 years of research in the proof of the EPR argument, we have accumulated a significant number of experimental verification in various fields, such as classical mechanics, particle physics, astrophysics, chemistry, and other fields. Those experimental verifications will be presented at the teleconference. However, in the event colleagues are interested in the preview, the experimental verification can be located in the third volume of Elements of Hadronic Mechanics, which is dated 2016. And this is the link for its free PDF download. I should indicate that all those experimental verification can be considered indeed as experimental verification of the EPR argument, at least in my view, because all of them are inconceivable via quantum mechanics, cannot be elaborated with quantum mechanics, and can only be elaborated, predicted, and treated via its completion into hadronic mechanics. Thank you for your attention.